got back from vacation, so a little bit hectic on a Monday. I'm sure you understand.
Yeah, for sure.
Cool. So yeah, before we get started with the coding portion, I just wanted to chat a little bit. I did look at your resume, gotten to do some pretty cool high impact stuff, especially recently.
Thanks.
So can you tell me a little bit more about like why you applied to this role and like what specifically interested you in it and in general? And so what's your comfort level with C++?
I'm not comfortable enough to code in an interview for it, but for day-to-day
Okay,
stuff,
good to know.
Yeah, I usually try not to interview in C++ because it's a headache with all the syntax issues and making the code more verbose. I only have 30 to 40 minutes to get through the problem, so.
Yeah. So one thing, just a heads up, I can skip on doing C++ today. I was going to have you do C++ today, but you probably want to get comfortable if we move on to the on-site, because the C++ is a pretty hard requirement for our team, given the type of work we do. So cool. Can you tell me a little bit more about one of your recent projects over the last couple of years? Maybe some things that you wish you'd done differently, or like key lessons you learned from those projects. I'd prefer it be something like technical related. So like preferably given the type of role you're applying for, like high level design decisions, something like that. Okay. I think let's get into the technical portion, but I'm going to try and leave some time at the end so that you can ask me questions. So just a quick overview though. So I work on the Guardian controls team. So I actually work under and I've worked on controls infrastructure that you would be working on in this role. So if you have questions specific to that, you can actually ask me about that. These days, my main focus is like system validation verification. So that's sim tests, fault tolerance, fault injection, human in the loop tests, bunch of stuff. So yeah, but why don't we open up the interview and in HackerRank and get started. So just I think let me post something in here.
Okay.
Just make it more clear. Cool. So basically, a high-level overview is that you have an infinite two-dimensional grid with n number of obstacles on that grid. You're supposed to find the number of actions to go from location A to location B on that grid. You're doing path planning for a robot that can move in the manner described below. I provided a sample grid with like possible move locations below. The robot jumps so it can ignore obstacles that are not directly on the locations that it can move to.
Okay.
Do you have any questions so far?
So unless I'm blind, I don't see any B's inside the grid.
So A and B just like refer to like your generic starting and ending location. This example below doesn't have a target goal. This is just showing, okay, if you're at location A, you can move to any of those other locations.
Okay.
Does that make sense?
Yeah, one second. In the top right corner where it said the language is actually cutting off the text, so I can't see all of it. Let me my screen.
Here.
All right, yeah, might help to. All right, I can probably do it. There we go. Okay, there we go. Let me quickly read through this and then ask any questions I have. Given an infinite 2D grid with n number of obstacles on the grid, find the optimal number of actions to go from location A to location B on the grid. You're doing path planning for a robot can move in the following manner. See below. A is the starting location while C is any place where the robot can move. The robot jumps so it can ignore obstacles that are not exactly on the location that it can move to. Okay. What are the obstacles here? Are the zeros, or that's an open space?
Yeah. So basically, obstacles. I'm leaving this a little bit open-ended because you can decide how you want to represent obstacles.
Okay.
It could be like a 1, whatever you choose to decide.
Okay. The next location I can move to. C is any place where the robot can move. Okay, so the input is some 2D grid. Input 2D grid of integers. And what is the output here? A list of paths?
Yeah, so the output is the length of the shortest path.
Oh, the length of the shortest path. Okay, length of the shortest path. A to B, and B in this case is any of the C's.
No, so a B would be some like arbitrary location on the grid. So like if we wanted to put it here, like for example, we could put the B there, and then the output would be in this case 2.
Okay, so location. B.
Now, one thing to keep in mind, I'm not actually specifying what your input is. If there's something more efficient than a 2D grid of integers, feel free to use that as well.
Okay, so just to understand everything, so all the potential values that we could have is A, which is a starting location, B, which is an ending location, C, where it says any place where the robot can move, so possible moves.
So C isn't a variable that you're given. I'm just trying to highlight how the robot moves with C. So C isn't an input. It's just this is just me highlighting how you can. So like basically the robot moves like a knight.
Okay.
Are you familiar with chess?
Yeah.
So some people don't understand when I say.
Yeah. Does that imply you can always move from at least one C to the ending location B?
Are you asking if there's always a solution?
Yeah, because let's say the knight can only move in specific places, but if a b is next to a c and there's no c nearby that can get to it, is that ever a case?
It could be a case if there are obstacles that block a possible path.
There could be no solution. There could be no solution. All right. Just or something arbitrary. Go. So a starting location, and I know you say I have some freedom over how I want to define the inputs. So for the starting location, I'll say it's a tuple. We have some I,
Yep.
j position. Is that fair?
Mhm.
Okay, so starting location's I. Similarly, B in the location some I, j position, and then C is a possible move. So if you're at A, so is there some, let's say, inbuilt function within the robot that says get next possible moves? How do I know what the next possible moves are from our starting location if I don't know if it's a knight or a queen or a rook or any possible scheme?
Oh, sorry. It always moves like a knight.
Okay, always a knight. Okay, got it.
Yeah.
Yeah, specify. So we'll just specify knight. So you're here. So if I'm at the start position, I can show an example on 10, and I'm A, and I have essentially my next possible moves would be what's already the nearest C's, essentially, because those are the next positions that it could move to. So it's the first two at the top, these two right down here, and these two, and then these two. So that 2, 4, 6, 8. So there are 8 next possible moves from the start location, just for this example.
Yeah. Just to clarify again, you're not explicitly given C. These C possible moves.
If I were at some random places, if I were to find the next possible moves, it would be these C's, but there's no C given.
Yep.
Okay.
Yep.
Is there a case? Okay. And hypothetically, any of these C's could be an obstacle, which means I couldn't move there.
Yep.
Okay.
Yep. Exactly. Yep.
Any of these C's could be an obstacle, so I cannot move there. All right. So for those cases, all right. So in that case, there might be more questions I can ask, but let me start with another approach, and then I'll ask you any further questions if anything pops up. So given a start position, so in each case, I want to say, given start location. And essentially, this is a BFS problem since it's shortest path. So BFS problem. So for each valid move, to be in those cases, run BFS until the destination is reached. And let me see. So for each valid move, run BFS until the destination is reached. If so what's a valid move? A valid move is not an obstacle. It is not an obstacle. Run BFS until the destination is reached. And okay, so if I'm running BFS, I'm at this path, and this one runs into an obstacle, then I can terminate that. I would have not else terminate traversal just for that path. Otherwise, I keep exploring all the path. And the first one that gets to the destination would be the shortest. Return first path that reaches destination. Since you mentioned there's a case where there could be no solution, then I probably need some visited set so I can keep track of what I've seen already, so I don't end up in an infinite loop where I keep trying to explore paths over and over, in which case the destination isn't reached. So declare visited set to keep track of paths seen in the case of no solution. And in that case, I just return, in which case, return -1. All right, so in that case, solution.
How do you determine whether or not there's no solution?
How do I determine if there's no solution?
Yep.
So I'm thinking, because if I have a grid, if I move, let's say, up, up, technically you can always move with BFS down, down again. So you can end up in an infinite loop where you keep going up, up, down, down, up, up, down, down. The only way you can prevent that is if you have a visited set to keep track of where you've seen so far. So in this case, for example, all the C's in this example, all of those would be added to my visited set. So if I ever go back to a C, I know that, I mean, it's probably in some loop. And if no path can expand from any of the non-visited places, then I know I can't get to a destination. If there's not at least one C where I haven't visited and it's not a valid move, then I know I can't get to the destination.
Okay. And in what case, like, is that always going to work? Are there going to be cases where that doesn't work?
Let me see. If it's longer, what would happen in a case where it's longer? Let me think. If I'm at A and I go here, if I go there, I'm trying to think because if I'm at A and I run BFS and get these C's, which are all the next possible moves, I essentially filter out all the non-possible moves, the ones that are obstacles. So I have some positions that remain, and then I can move to those.
So just to interject and point you in the right direction a little bit, remember, this grid is infinite.
Okay, I've completely forgot about that.
Right. Yeah, you might want to reconsider a few things based on that.
Forgot about that. So it's an infinite 2D grid. In that case, that's a heuristic I could apply. Okay, let me think. So if I'm here, so it's BFS and not DFS. I can't imagine a case where I just, for example, just keep going all the way up and I'll never get there because I'm always going to the closest ones.
Yeah.
So with BFS, if I can imagine a case where if all the positions I'm at are greater than the destination, then that means there's no way to get back to the destination. Because you can imagine
basically past the destination.
Yeah, exactly. So let me
Gotcha.
make a note of that.
What if there's sort of a solid barrier in sort of like a horseshoe shape that moves, like that causes, so there's like still a path, but you have to go fairly far beyond the destination to like find the right path.
Yeah, that's an interesting point. You have to go all the way out, then eventually get to a path that takes you back down. Yeah, that's interesting to think about. How would I catch that? Let me think.
I do want to make sure you have enough time for this problem.
Yeah.
So if you want, we can just like go forward with the BFS approach.
Yeah.
And then come back to thinking about that more at the end.
Yeah.
Another question is, does your input change based on this being an infinite grid?
Does my input change?
Yeah.
So the input, I assume it could be any point. Well, you can't really have any point in infinite grid because it's technically infinite. Are there any constraints I can put on the starting point?
Nope.
Okay, no constraints. Because I can only have one starting point. So theoretically, it could be anywhere in an infinite grid, even if it's infinitely far away from the destination.
Yeah, in theory.
Yeah. So in that case, it would still be a tuple, right, of some xy position.
Yeah.
Yeah.
Yep.
All right, so I'll try to quickly code up the regular BFS. Hopefully that'll give me some hints about how to address the infinite cases you're mentioning. So if I just define regular BFS, I say starting. Fine. What is it called? Fine. Okay, so find shortest path, and that takes in some starting position. What else? Take some starting position. Destination. Let's see. So perfect. I probably have to write some possible next moves since it's a night. Next moves. Position. So return a list and what are the possible moves? So it's 2, 2, 2, 2. It should be 8 positions. So it's curve position. Let me write that down. So up, up, left 1. Okay. So I can better keep track. So it's curve position 0. So 1, 1, and then this. Okay, so this one is 1 to the left. And then 1 up 2. Let me lose. 2, 3, 4, 5, 6, 7, 8. All right, so that's up, up, left, and up, up, right. So this one is +1, and then position 3 is.
I actually want to. Why don't we save you some time? You can come back to this later if you have extra time. Let's focus on the other aspects of the problem.
For sure, that's gonna take time. So let's say you have some starting position. Let's know. Need some Q. Positions. Import back. Say Q dot append. It's gonna be starting position. I need my visited equals to set, and then I can say visited add starting position. And if I'm at file of q, I can just do walk q. It's empty, so walk q, we say position equals to q dot top left, and then I just want to go through. So I'll just assume I had fully implemented this. So for get next moves in position. So if I get all the next moves in position, what do I want to do next? So for next move in position, I need a is valid. So if I is valid move, say position. So if obstacle, if grid, grid x y, if not, if y is equal to obstacle, just return not grid x y is equal to obstacle. Okay. So for each of those moves, if is valid move position. So for each next move, what am I doing? So if it's a valid move, I want to do in this case. I'll add to my queue, so I keep exploring. I also have to check to make sure it's not a destination. And position, that's my visited as well. So all queue position can pop there. So if starting position is equal to destination, then I return. Instead, I should return the length of the shortest path. Length shortest path equals to. How do we define length? Is it number of moves or the actual like
number of moves?
Okay.
Number of moves.
So length shortest
Good question.
path, no moves. So in this case, for each of these, at the end of my for loop, I'm gonna say length of the shortest path is equals to 1. Right, so in the beginning, if the start position is destination, then long shortest path is 0, so I return that. And then if I have to go to the next possible moves, I increment that by 1. Okay, so that part's good. And then the visited. So this is most of the BFS. I want to pause here to go back to your question about the infinite grid. And I'm wondering if the visited would hurt me in this case, because I'm trying to see if there's a case where going back to a visited point could lead me to. No, that's not possible. So at one point, I'll always get the next possible move. So yeah, I definitely need visited. So let me check what I want to. So if it's valid, so valid position. And so, yeah, so if it's valid position and not position in visited. All right, so it's valid. Haven't seen it already. Add it to your queue. Add it to visited. All right, so this is regular BFS. Now let me get back to your question about the infinite grid. So your question was, how would I handle a case where it's horseshoe, for example, like invisible barrier, where I'd have to go
Right.
around it to get to the destination.
Yep.
Let me think. I know we don't have much time. I wanted to sort of write things down on paper if that might help. But
So just a quick question. Does this like does everything here sort of like cover what you want to do for like a basic BFS?
Yeah. So I'm at some position.
Okay.
I've visited. Keep track of everything in the queue. Yeah.
Okay. And do you want to quickly like run through an example to make sure it returns what you would expect?
Yeah. Let me go over it again and see if I'm forgetting anything. So I have get moves. Well, it wouldn't work with my get moves function not working. So
Yeah. Let's assume that works.
Okay. So you're saying run through an example without running the code?
Yes.
Okay. So if I'm at some start position, let's say 3-3. So I'm at 3-3, get the queue. So add 3-3 to the queue, add 3-3 to the visit set. I'm saying while queue, I get that 3-3. If 3-3 is equal to destination, so start position 3-3 is equal to the destination position 3-3, then I'd return the number of paths seen so far. Otherwise, now we mentioned B. I guess in this case, I'm assuming the destination is what happened. I assume the destination is just XY coordinate instead of an actual letter B.
Yep.
Yeah.
Yep.
So if that position is equal to that position, that's good. So then I get the next possible move from 3-3. It would give me 8 possible moves. For each of those 8 moves, I would say, okay, is this move valid? And if it is, and it's not in visited, so I haven't seen it already, then add that next position to the queue. Add it to the visited, because I visited it. And I keep doing that for each of the positions that BFS gave me in the first traversal. And then I increase the shortest path and the moves seen so far. Yeah. And then, well, I don't actually give a case, return one. In a case where returning in a case where it doesn't find any paths.
And can you the number of moves of the shortest path?
Yeah. And yeah, so inside on line 64, say if the starting position equal to destination position, once that happens, that implies already because of BFS is the shortest path.
Len shortest path no moves is not measuring the number of moves of the shortest path.
So if I do that, I go through all the next ones, then I pop left.
This variable is counting how many paths or how many positions you look at.
Positions to look at. Oh, yeah, because I have that start position right there. So I probably want, where would I want to put it on? From here, I go here, and here. When do I increment shortest path on moves? The queue, and none of that. So 4 position, get next position if it's valid. Okay, so this I probably want to position, get left, get the next position for that. That's right. So in case I'm right here, I'm here. So I guess I check while I'm trying. So if I say, so I'm at the start position, add that in there, then I say 4 possible moves and get next one. If I move this, different position, move this one, get the first one out, next moves, then I say if that's valid, and then this. So then I say, I'll queue, move these up, queue, and then I want to say position.
Interesting. So I see what you're trying to do here. Basically, you want to go through the entire queue.
Yeah.
Essentially, an entire layer, and then increment, and then go through an. Okay.
Yeah. So for position.
So I do see what you're trying to do.
Yeah.
However, you're going to be continually adding to that queue, so it's never going to run out.
Like in the case where the next one, then at the end. So the end of 4 next moves. Yeah. How do I address that? So in this situation, what if I think, what could I do? So I'm here, have the grid, have the queue, add to the queue, I go through, I mark it. So while queue is good, then I do the 4. Okay, now so I definitely need the, first if I have white queue, and then I take the position out. If it's not equal to that destination, the next possible moves, if it's good, add to the queue, add to the visited. Then I would want to, what would I do next? Let me think. What would it be?
So how do you how do you know, let's say you're looking at the queue, before you start looking at a particular layer of the BFS search, how do you know how many paths you'll need to explore?
So it would be, so you have 8, and then from 8 you'd have, is it 2, 8 to the 1?
It's going to change based on obstructions, based on obstacles. But if you think about it from a coding perspective, how do you know in advance, or not in advance, but sort of as you're running the code, how do you know how many nodes are in a particular layer?
How do I know how many of the nodes are in a particular layer?
Yeah.
So I know, let's say there's some layer 0, which is a starting position. It's the maximum number, which in this case would be 8, minus the number of obstacles at that layer. For the first layer. And then the second layer.
How many? So when you start out, you just have one node that you need to explore.
Yeah.
Right. But then based on that, how do you measure how many nodes you're going to need to explore next?
How do I know?
After you run that one node through, once you run your starting one through.
That's a good question. How do I know? Here, and get the next 8. Really, just thinking about examples. The first one is 8 minus the number of obstacles. Then for each point, it's another 8 minus the number of obstacles.
What about this? Any ideas there? You see where I'm headed with this? Right, because
well, that's get next moves, isn't it? Okay, I see what you're saying. Because if the queue has 5, then you're gonna have to do the same thing for each 5 of them. Okay.
Yep, exactly.
I see what you're saying.
Yeah, you almost had it.
Yeah.
Okay, cool. So no worries. Hackering. Lovely. All right, cool. So what ideas do you have? For how to fix the issue we were talking about earlier?
Yeah, about the infinite grid.
Yeah.
Let me think. So in the case you have a horseshoe, and you have to go all the way up, and then you come all the way down. And you say it has nothing to do with math. I don't have to think there's some constraint that.
I mean, you can do a heuristic approach, but that's not ideal.
Yeah. So what's the problem that you're saying? You're saying with a regular BFS where you try to find the shortest path, it wouldn't find the shortest path in the case of an horseshoe example? It wouldn't eventually get to it? Or is it time complexity?
Well, so it's more like the intersection of when do you stop, right? How do you know that you are running infinitely?
Okay.
How do you balance that trade-off with needing to stop eventually?
Okay. I get what you're saying now. So if you pass it, how do you know you're not going to end up just infinitely keep going over and over and over and over? Here. Let me think. What if... Okay, so right now I'm only running BFS from the start. What if I run it from the destination? Because I already know what the destination point is. So I imagine they would intersect at some point.
Very good idea.
Yeah. Because right now I'm only running on the start. Okay, so
very good idea.
Got all of these. Okay, how do I want to do that? If I'm here, right here, I do it in tandem. Okay. Let me think.
What do you mean by do it in tandem?
So if I'm running the BFS from the start position, I want to be running from the destination at the same time. So they essentially just increment to get closer and closer and closer until they intersect.
Nice. And why do you need to do that?
Because in the case, like you mentioned, if you have some start and you have some destination, and if you're going from, let's say, just a start and you're expanding out with BFS, well, I guess really it sounds like because So if you get two shortest paths, like it just intuitively makes sense, but it intuitively makes sense.
So
but to explain
what is it
why-
like? Why like doing it in sequence versus doing it in tandem? What are the pros cons there?
Yeah, in the case of the sequence, you wouldn't know when it would end because it would just keep expanding.
Yep,
and you'd end up
exactly.
getting closer.
Yeah.
So
you don't need to write it up. Honestly, so we're a little bit over time. I do want to leave you some time to ask me questions. But that good catch on that solution.
okay, well, yeah, I guess the question I wanted to ask, especially when you presented this question, this is definitely one of the more challenging questions that I've had to solve in 30 minutes in an interview. And since you said your team mostly develops in C++, do you find it, I don't want to use the word pleasant, but what's the experience on average for most candidates solving this in C++?
So most candidates do not solve this in C++.
Okay, so I was very confused at first.
Yeah, so if you had gone with C++, I would have given you a different problem.
Oh, okay, that makes sense.
Yeah. And also one thing that's unique about your situation is most candidates I interview are for infrastructure teams, while you would be working on a team that's sort of very closely tied to the robot and autonomy and like real-time control systems. So C++ is very much required.
Okay, that makes sense. So I guess I guess more closer to the heart of the problem, what are some of the challenges that aren't immediately intuitive that you have to work on at Neuro? So for example, if you're looking at finding the shortest path for the robot to go from one place to the next, let's say you don't think right away, well, how do I find the shortest path from the destination as well at the same time? What are some like unintuitive right away problems that you've encountered since you've been at Neuro? Like things you just didn't expect at first?
All right, here's a fun one.
Yeah.
So imagine a simulation system that is supposed to represent like real world driving.
Yeah.
How do you measure whether or not that simulation is a realistic representation of real world driving?
So that's a good point.
Yeah, that is a hugely complex open-ended problem.
I assume this is a problem every autonomous vehicle company has to go through. So like Waymo, Tesla.
Yes and no. For us, it's a little bit more complicated.
Okay.
In some aspects, because our teleoperation stack is designed differently.
Okay.
Yeah, I can't go into the details too much, but there are aspects of our teleoperation stack that impact that sort of research question.
Yeah.
Yeah.
How long have you been at Neuro? What was your background prior to coming to Neuro?
So I've been at almost 2 years, although it feels like a lot less.
Basically all COVID.
Huh?
Basically all throughout COVID.
Yeah. Yep. I was at Microsoft before. I worked on everyone's favorite Microsoft product, Windows Update infrastructure.
So basically a very different product.
Yeah, very different product. I do have a background in machine learning and biometrics and security.
Yeah.
Sort of the combination of those fields. So I did research in that area for a while. I think it's mostly interested in me because I have a pretty robust engineering background plus a research background, which is fairly rare to find in people who don't have a master's degree or PhD.
Yeah.
And I actually did not know C++ when I joined the company. Yeah.
Did you start on this team or did you start on another team?
I started on this team, but I also joined at a lower level than this position is open for. And also not control system specific. Yeah. So that. What was the other aspect of your question?
I think the first question was how long, and then the second question was what was your background before?
Yeah. Okay. Cool. Yeah. Yeah. So, but yeah, I really enjoyed the team. Fantastic manager, probably the best I've had, even though he has not been a manager as long as any of the other managers I've had before.
Yeah.
I just think he's an excellent engineer himself, and he knows what drives engineers crazy, so he tries not to do that.
Yeah, makes a lot of sense. Awesome. Yeah, that mostly covers what I wanted to ask.
Cool. Yeah, it was really great chatting with you. Any last questions?